Okay, we're going to move on to quadratic equations, and here our variable has a square term, and we'd like to find solutions to equations that look like this: ax squared plus bx plus c equals 0, where a, b, and c are real numbers and the coefficient of x squared is non-zero. In other words, there certainly is an x squared term in the equation. Now, the real solutions of a quadratic equation are real numbers x which satisfy the equation and make the statement true. And there are three possible scenarios. The first one is that there's exactly one real number which solves this equation. The second scenario is that there are two distinct real numbers which solve the equation. And the third scenario is that there are no solutions in the real numbers, that there are no values of x in the real numbers which satisfy this equation. In this case, there are two solutions, but they're complex numbers. And there are a number of ways of approaching the solution of these equations, and all of which are very useful. The first one is just by factoring. So we've already figured out how to factor an expression that looks like this. And there's a very useful algebraic property. If I multiply two expressions a and b, two real numbers a and b, and I get 0, then one of them has to be 0. And vice versa, if one of these numbers is 0, then their product is 0. So I say a times b equals 0 if and only if a equals 0 or b equals 0. This if and only if means that if this statement is true, then the one on the right hand side here is true, and vice versa. If the one on the right is true, then the one on the left has to be true. So we can use this in our factorization techniques to solve some quadratic equations. For example, suppose I have the equation x squared plus 10x equals 24, and I'd like to find the real solutions. Well, the first thing is I write it in this form: ax squared plus bx plus c equals 0. And then I try to factor the left-hand side. So remember, x squared plus 10x minus 24 is equal to x plus a1 times x plus a2, and a1 times a2 must equal minus 24, and a1 plus a2 must add to 10. If I can find such factors. So I'm looking for two such numbers. So thinking through the factors of 24, I think 12 and 2 are likely to work out. I have to decide on the signs. So I must have the sum of these two equals 10. So 12 minus 2 equals 10. So I should give a plus to the 12 and a minus to the 2, and then when I multiply, I get negative 24. Okay, now I have a statement like this: a times b equals 0. I'm assuming x is a real number, and if I take the product of these two, I get 0, so therefore the right-hand side must be true. Either, if this is true, then either x plus 12 equals 0 or x minus 2 equals 0. And that's the same as saying x equals minus 12 or x equals 2. And both give me solutions to the equation, because when x is 2, x minus 2 is 0, so that means that all of this is 0. And when x equals minus 12, x plus 12 is 0, so that means that this whole expression is also 0. So those are my two feasible solutions. They're exactly two real numbers which fit this equation, and that's the full list there. If I'm given an equation, a simple quadratic equation, x squared equals c, where c is some number greater than 0, then it's very easy to solve this. X is either the square root of c or negative the square root of c. Note that if I was given an equation x squared equals a negative number, then there are no real solutions, because squares are always greater than or equal to 0 when x is a real number. So these equations are very easy to solve, and they're going to help us come up with a formula for the general solution of a quadratic equation. Here's some examples. Suppose I want to solve the equation x squared equals 9. Well, x squared equals 9 is the same as saying that x equals the square root of 9, or x equals minus the square root of 9. And that, of course, can be simplified. X equals 3, or x equals minus 3. And a simple way to write that in one sentence is x equals plus or minus 3. Now, this one isn't exactly in the simple form, but I can still use the general solution here to solve this equation. So instead of x squared, I have x minus 2 squared, and that means that if x minus 2 squared equals 16, x minus 2 equals plus or minus the square root of 16. So x minus 2 equals 4, or x minus 2 equals minus the square root of 16, which is minus 4. And now I have two equations, and I can solve for x in both of them. So I get x equals 4 plus 2 here. Or, on the other hand, I might have x equals minus 4 plus 2. This gives me x equals 6, or x equals minus 2. So I have two solutions to the above equation, either x equals 6 or x equals minus 2.